Hello everybody and welcome back. Well, the mystery has been solved. And thanks to several of you viewers who really came out of the woodwork and just must have spent a lot of time helping with this, I was able to find out quite a bit about this type of circuit. And it's kind of related to some things that my cousin many years ago kind of showed me, but not the same in other ways. What this is called is a simplex stereo circuit. Now what you're looking at is kind of a redraw of the schematic, and I did this myself to simplify it a little bit. What we did was we took away all of the components used for switching into mono mode, and we focused strictly on what's necessary for it to work in stereo mode. And I still did not really change much of the circuit at all. As a matter of fact, this circuit as it sits will not work for several reasons, and we'll explain that in a minute. But this is a redraw that I did, and what I'm going to share with you throughout the rest of this video after we explain the circuit a little bit is a series of 16 images that are pages taken from some magazines back in the late 1950s, early 1960s that explains this simplex circuit. Apparently, CBS Laboratories back in that time came up with this very unique circuit to be able to create stereo sound using only two output tubes and without using a phase splitter or two separate preamp or driver sections or anything like that. So it's a very unique circuit and it's very interesting, but as they say, there's nothing new under the sun. And as the reputation for Big of California goes, they really didn't invent a whole lot of things, but they used a lot of common circuitry at the time, put their own little spin on it, and released it as their own house brand amplifiers. And that's looks to be what this GD108 stereo amplifier is all about. So let's talk a little bit about the circuit as I have it drawn right here. Now the first part we're going to look at, and if you see I have it circled in red, are the output transformer, or should I say the output transformers. Take a look at this. Where you would normally see in a monoblock amplifier design like this with push-pull outputs, you would just see the transformer up on the top. But if you notice below the main output transformer, you'll see this other little transformer underneath there. Now, this is a little bit different than the articles that I'm going to show you from these magazines. This is one of the differences in this particular amplifier, and I'm not sure if it's original to the amplifier or if this is something somebody swapped out at some point in time. But what I do know is the transformer in the amplifier that we have is considerably smaller than the main output transformer. Now what they talk about in the simplex circuit is they use two identical output transformers, and there's a couple reasons why I see a disadvantage to that, but also in this we may have a disadvantage. Let's take a quick look at the actual photograph of the amplifier. Taking a look at the underneath of the chassis of this thing, you have this little transformer here that says sample on it. And this is actually a single-ended audio output transformer. Very interesting. It only looks to be maybe a 3 to 5 watt output transformer. That's all I think it would be at this physical size. We don't know for sure. But when you compare it to the transformer, the main transformer, when this was originally a 50 watt monoblock, they're very different in size. If you look at the transformer on the left and you compare its size to these 12AX7 tubes or ECC83 tubes, you can see how large this is. This is a potted transformer, but still the transformer inside of it is much larger than what you would see, what you were just seeing underneath. Once we learn how this circuit works, that might kind of raise a red flag, as that I don't know if the small single-ended transformer can handle the amount of power that this amplifier is designed to output. Now, the way this circuit works, I'm not going to go into great details right now because the articles that I'm going to show you later in the video explain it much better than I can just talking to you. But essentially, think of it as any of the signals that are going to be mono or any of the signals that are going to be common to the right and left channel will be produced through this lower transformer, through the bottom transformer. The bottom transformer actually derives the common point for your left and right channel, or left and right speakers. And then if you look at the top, that top transformer, you have one channel connected to the 8 ohm tap, the other channel connected to the common tap of the output transformer, and the 4 ohm tap, which is exactly center between 8 ohms and 0, is connected to that lower transformer. And it's doing a trick with phases and so forth, which we will read about later on. And the problem that I see with this is that, being that that is a smaller transformer on the bottom, I don't know that it will be able to handle all of the current that two EL34 tubes basically in parallel will work. Why am I saying in parallel? Well, when you have the common mode signal going on and both tubes are being driven in phase to one another, you're not going to get a changing magnetic field in the top transformer, because as you increase the current on the one side, you're also increasing the voltage and current in the other one. So the power of both tubes goes up and down together in an equal and opposite manner, which will cancel itself out in the primary of that top transformer. However, that changing current and changing voltage will reflect down onto the primary of that lower transformer down there. And that changing current will reflect from the primary to the secondary of that bottom transformer, allowing that signal to pass down there. So what will happen is, think about this for a minute, the one side of that secondary of the bottom transformer goes to your common of both right and left channel speakers, whereas the other one goes through the upper and lower section, the 4 ohm tap and the common tap, out to your right and left. That will be essentially like having the two windings in parallel. So you have to kind of think of it like that. And so you will get a mono output from both right and left channel, and all of the power will be coming from that lower transformer, not from the upper transformer. I know that sounds a little bit complicated, but that's really what's going on here right now. So think about that as you have two EL34s in parallel and their full power going through that little tiny transformer on the bottom. I believe that transformer is a bit undersized for what it would need to be, even though it's considered a single-ended amplifier. Let's talk about something else now. Now, what you're going to read in these articles is that they are using two identical output transformers, and they are both two identical push-pull output transformers. Let's see if we can flash a picture of that up there right now. Here's one of the schematics from one of the magazine articles. And if you look, I'm zooming in now on the transformers. They're using two identical push-pull transformers. Now, this probably will not work, or would not work well, because if both transformers are push-pull, that means that they do not have an air gap in them, and they are not designed for single-ended use. In other words, you need an equal and opposite voltages on the two outside taps of that transformer in order for the lower transformer to work properly. If not, you're going to saturate the core of that transformer and it's not going to work. So this circuit, the way they're recommending it there, my prediction is that it will not work because the transformer will be saturated. So this one, and we will see all of these later, this circuit is probably not the best one you'd want to use out of the ones that we're going to see. Now this next one that we're looking at is the CBS Columbia 951 phonograph amplifier. And if you notice, it's a little bit different than the one we just looked at, right? The top transformer is a push-pull transformer, and the one at the bottom is a single-ended transformer. And the bottom one most likely has the air gap in it, and therefore the core will not saturate from the standby current of the tubes. This is a proper implementation of this circuit, and this one would probably work much better than the first one we looked at. Now that first one, strangely enough, was from a 1959 Popular Electronics magazine, and it was from an article showing you how to design and build one of these yourself. And they were recommending that you use 2 identical transformers, and in their case 2 identical push-pull transformers. So I think that there would have been some disappointed builders if they followed that article the way it was intended and built that with 2 push-pull transformers. I think that would have had a lot of distortion and noise in it. It wouldn't have worked the same as this one. This is a proper implementation, and believe it or not, CBS Laboratories actually built these, and they put them into some of their stereo phonographs in the early days. Now, in order for this to work, they had to wire the phonograph cartridge out of phase between the right and left channels. That's how they did this. And that was pretty interesting as well. We'll get more into why that is the case in a little bit. But you can see that they were still working this all out back in the 1959 to 61, 62. Those few years was the popular time for this particular circuit. I'm not sure why they did it. The fact that you still have to have 2 output transformers, which is the most expensive part of an amplifier. Yeah, you could save on tube count by only having 1 push-pull pair of outputs and not having a phase inverter, but I don't think that would be a great enough savings, and that's probably why this thing fell out of favor. But it would have worked. So going back to our original design, you can see that is how Big of California designed their Stereo 50 amplifier with a single-ended and a push-pull transformer. So that part is right, but I believe that the bottom transformer might need to be a little larger. I'd need to see one of these in real life to know if that would be the case or not. But either way, the more we look at this, the more we can see how this circuit would have worked. Now, again, we're going to get into why I don't believe this one will work the way it is right now. Well, I know that it won't work. It's not that I don't believe. I know that it won't work this way. The first reason the current iteration of this amp won't work was, if you go back to the original drawing that Greg shared with me, where I have that circled area right now in the power supply, there was a center tap there, and it was showing that it was connected to chassis ground. Now, if you did that, you would be connecting your mains directly to chassis, which would be a big no-no. So that part, if you notice, I removed from the schematic, and that's one of the small modifications I did on this. I really tried to keep this original, though, because we'll change things on the schematic as we go along. But that was the first thing that I found. Now, the next problem we have deals with this circled area here to the left on the input section. If you notice, the 12AX7, and that's a typo, it's not a 12AU7, so you have to forgive me for that. But you can see those 2 circled areas. The 2 cathodes of the right and left input amplifier stage, or input voltage amplification stage, are tied together and then go directly to ground, to chassis ground. Now what that's going to do is that's going to upset the bias of that stage of the of the tubes, and therefore you will either get a lot of distortion or no sound at all, because you have to cathode bias this the way it's designed. So you would have to, because there's no voltage on the grid of these tubes or no negative bias, you're going to have to get that cathode voltage raised up a little bit. So there needs to be a cathode resistor. Now they could, couple different ways I guess they could have done it. They could have either put a resistor between the tie point of the two tubes and ground to kind of make them have a shared cathode resistor, or give each tube its own individual cathode resistor. But either way, you need that for this thing to actually work. Okay, now that we've had an introduction to this, let's now start looking at some of the articles that we found. And I take no credit for this whatsoever. It's you viewers that did this, and I owe you a debt of gratitude for it. You did a fantastic job on this. And although I had heard of phantom channels, which is another name used for the simplex stereo amplifier, there's another meaning for phantom channel, and that is where you have an already stereo amplifier and you pick off the 4 ohm tap of the left channel and the 4 ohm tap of the right channel, and you derive a center channel that is a kind of a combination of left and right together. So you would have a left, right, and center channel. Some of the Fisher amplifiers back then did that as well with this phantom channel. But anyway, let's look at these articles now, and I'll kind of narrate a little bit of them, but really I ask you to just stop the video on each one of these and read them, because it's very interesting reading. I hope you can see these here on the screen. If you have a computer, maybe on your phone it might be a little difficult, but here we go. Okay, the first article we're going to look at is from the October of 1958 edition of Audio Magazine, and it's a 2-page document that shows and does a very good job of explaining how the two-way, they call it a two-way stereophonic amplifier, how it works. And if you look in the article, it does explain the math a little bit, or the phase relationship between left and right. I'm going to kind of go through and we'll look at each of these, and then I'm going to point out something common to all of them that doesn't seem to be common to our GD108. The next one is from a 1959 edition of Radio News, and it gets into more detail yet about how this simplex circuit works. Now you'll see a common thread is they do give a lot of credit to CBS Laboratories for this, and apparently this was a very popular thing for just a couple of years when stereo was just coming out and it was in its infancy. So again, you can feel free to stop the video at any time and to read the pages. Now this next one is from the April of 1959 release of the Popular Electronics magazine, and by far this one seems to be the most interesting to me. They start off with this really well-written article about stereo simplexing, simplified they call it, and it goes through and explains step by step how the simplex stereo configuration works and how these circuits function, and it gets really into the meat and potatoes of how it works. Then it follows up with another article, and the next article here that I'm going to show you here, it'll pop up in just a second. This follow-up article actually shows you how to build one of these, and it starts out by giving you a page with a bill of materials and a good schematic, and then it goes on and goes through the construction instructions, how to actually punch out the chassis and to wire it up and to make your own simplex stereo amplifier. Now, unfortunately, this is the one that tells you to use two of the same output transformers, which that's the one that would kind of get you in trouble because of that single-ended one needing to be an air-gapped transformer. So I'm not sure how this would have worked if you'd have gone out and purchased the parts and tried to build it. Although the only thing you would need to do is just replace that bottom transformer so that it would be a single-ended one. This last article is from September of 1959, Electronics World magazine, I believe. And it's another article about the simplex type stereo amplifier, and it goes ahead and it shows you how to build one and design one from their little schematic and bill of materials. So it's very similar to the previous article. Now, going back to the original schematic that Greg shared with us, that he so wonderfully was able to put together and make, you'll notice that there are a couple of switches. So right above the power supply and below the first output, the big output transformer, you see a double throw switch, or a double pole switch, I should say. And at the input, right between the two input jacks, you see another switch. And those are your stereo and mono switches. If you recall, this amp had the ability to switch between a 50-watt monoblock amplifier and a stereo amplifier just by throwing two switches, the input switch and the output switch. How he did this was a little bit confusing to me, and I was trying to figure it out. And lo and behold, there was another article that we found, and I don't know what magazine it was out of, but somebody shared with me that actually had the ability to switch between stereo and mono mode. So let's put that up right now. Here's an example of yet another stereo phono amplifier. And if you look in the lower right-hand corner, you have a switch that says mono and stereo. And just above that to the right, you see external speaker. So essentially what you're doing is when the thing is switched into mono mode, you're shorting out the lower transformer, taking it out of the circuit. And all of the sum and difference, everything is going to go from both channels into the upper output transformer. When you switch it into stereo mode, it unshorts that transformer at the bottom, and it connects the external speaker into the circuit, just like all the other simplex designs are. Now, that might be what we were doing, in our BOC amplifier, but if you remember, not only did it have an output stereo and mono switch, but it also had an input stereo and mono switch on the front panel. If you notice, there is no way to invert the phase the way this thing sits right now. And in addition, well, let's get into the rest of that later, but you need a phase inverter. So you would need to take something like what you see in the red square, that circuit, and turn it into something that looks like this original 50-watt monoblock version, the GD50 or G50D, whatever they called it, where you actually have the traditional voltage amplification stage at the beginning, then it goes into a cathodiene phase splitter through your two decoupling capacitors and into your second voltage amplifier and then into your outputs. So somehow you have to derive that phase splitter, which is that second tube over from the left. And I don't see how they would do that the way they originally had it wired on the original design. Now finally, if we go back to my redrawn schematic, you can see that something doesn't make much sense. At the input, we have these 4.02 microfarad capacitors. There's two of them coming off of one end of the volume or input level pot from the left channel, and two of them from the one leg of the input level pot of the right channel, and they're in series and they both go to ground like that. Well, first of all, putting two 0.02 microfarad capacitors in series would be the same as just using a single 0.01 microfarad cap, which is a very common value. So why would they have done that? Number two, by having the capacitors in that particular configuration, your level pots do not have a ground to reference to. So really, rather than acting like an input level control, they would almost act like a base control, or like a high-pass filter, where that high-pass filter can filter the high-pass signals to ground, but not the low-pass things. And what's more, the tube cannot be properly it would be noisy because there's no grid leak there. Well, there actually is, because of that resistor I see in there. But really, those knobs would have very little, or those controls would have very little influence over the circuit. So that's another mystery. Another thing I noticed is the way that the negative feedback has to work in this simplex circuit. If you notice, there are two feedback paths, one from the left channel, one from the right channel, and they're feeding back to the second voltage amplifier stage, which that in and of itself isn't a problem, but again, it's a little bit different, and I'm not sure how that would work if we switched it into mono mode. It probably would, but I'd have to think about that. Maybe some of you can help me with that part. So going back to these capacitors, maybe this is part of an incomplete circuit, or a circuit where someone has removed components. If you remember, we had that convergence potentiometer in there, and I believe that the connection of that convergence pot may have something to do with creating an inverted signal. So what I'm saying is that maybe they're using feedback from further down in the amplifier stage somehow into the input stage, so that one of the tubes, one of those two tubes there on the left, is always 180 degrees out of phase from the other, which would be kind of like putting your phase inverter before your voltage amplifier stage, but I don't know why it wouldn't work. What I can't get my mind wrapped around is how they would have configured the circuit to do that. I guess it could be done, but and did these capacitors have something to do with it? Or were there additional resistors and connections that were put in there for the sole purpose of creating a inverted phase for one of the two channels so that you could have mono mode? I really don't know. Because really, the way this thing would work, you have to have, first of all, for the stereo mode to work, you have to have, and if you read those articles, one side of your phono cartridge had to be flipped or reversed. The phase of the plus and minus of the left channel, for instance, would have to be reversed with respect to the right channel of the phono cartridge. In most other sources, like a tape deck or a tuner or something with a preamp in it, they share a common return point. So you only have a 3-wire system. You have left, right, and common. And the left and right each share the same common, so you really couldn't reverse the polarity on them. So begs the question, was this amplifier only built for phono only? I don't know. It would have to be, or that mono mode, again, would have to do something to create a phase inversion. And if you wanted to not be able to flip the inputs of either the left or the right, somehow you would have to have one of those two tubes always inverting. So it would almost make more sense to have one of those tubes come off of the cathode, or come off of the anode like it does, and then have the bottom tube, for instance, being a cathode follower. Of course, that's going to cause other strange things, but at least you would have a inverted and non-inverted stage. And then you could keep everything connected properly. But anyway, that's the final part of this mystery that we need to solve. We at least know now that where George got and where BOC got this whole concept from, and obviously it must have worked. But how does he switch between stereo and mono mode? And can this amp work with something other than a phono cartridge, a ceramic phono cartridge, I might add, that that has the inputs flipped around like that? And a last final comment, this would have had to have been a ceramic phono cartridge to have enough drive voltage, number one. And number two, there is no RIAA equalization stage at the input. So if you used a magnetic phono cartridge, it would sound really bad because you don't have the de-emphasis circuit in there that you would in a normal phono preamp. All right, that's where we are right now with this, and this is mostly a reference for Greg. I hope it's helpful to him, and I hope it was interesting to all of you. Finally, as always, I want to wish you all peace, joy, happiness, and good health in your lives. And we're going to be getting back to the Fisher, or the Fisher 800B. The capacitors that I needed for it came in. I'm really excited to get back on that project, and I'm going to give Greg a good amount of time to work through this on his project, and when he reports back to us what's going on, I'll share that with all of you, and we'll see what we come up with, and hopefully we'll have a working amplifier. And I may just take an old chassis I have with a single-ended tube amp on it, and maybe I'll punch some holes in it, and it's a homebrew amp anyway that I don't use, and maybe we'll try to build one of these. That might be a fun project to do later on. So until that time, stay well and take care, and we'll see you soon. Bye-bye.